So I'm back here with example 3. Now this time you can see that it is a little more complex than any of the previous examples that we have seen here. One of the things that is going on here is the product, and then there's also the quotient. Okay, so guys, before we start working through this problem, one has to figure out which rules or what combination of rules one can use here. Guys, there's more than one ways of doing it. Sometimes people just like to treat it as a product of two functions, which is kind of obvious. You can think of this as function f and this as function g. Then you can go from there, starting with the product rule right away. Guys, I'm not going to use that method, that method is a perfectly fine method, perfectly valid method. Guys, what I would like to do rather, I would like to combine this guy with this numerator and then simplify them and just make it just one ratio of one polynomial divided by the ratio of the other polynomial. Once I have it in just a ratio of two polynomials, then I know we can just use the quotient rule, because quotient rule works for the quotient or when we have a polynomial or any quantity divided by the other quantity, right? So that's what I'm going to do here. So my first step would be to simplify this. So I'm going to rewrite this as x squared minus 1 times and then x cubed plus 3x squared, and I am not disobeying any mathematical rules in that. That is obviously, like, we already know that there's an invisible 1. There's supposed to be an invisible 1 here. So when you are multiplying these guys, it's like numerator times the numerator here and the denominator times the denominator. Multiplying over 1 is not going to change anything, so I'll still have x squared plus 2 here. Now if I got to simplify more, what I have to do here is, again, I got to do this whole distribution thing. So guys, let me try to do it right here. So I will get x squared times x cubed will be x to the power 5. Then the second term will be I still want to do with x squared first. I want to multiply this first or distribute this first. So this times this is plus 3x to the power 4. 2 plus 2 is 4. Then I'll go to negative 1. What do I have? I got just negative x to the power 3. And then finally I have minus 3x squared. So they're all different terms, so there's no way I can combine any of these. And in the denominator I have x squared plus 2. Right? So guys, I have a ratio of two functions, and then because I have a ratio of two functions, I can just use the quotient rule on them. All I have to do for the quotient rule is treat this as my f function and treat this as my g function, and let us recall or rewrite the quotient rule. Guys, the quotient rule looks like this. You have to do f prime times g minus g prime times f, and we got to divide everything by the square of the denominator, which is in this case going to be g squared. This is my quotient rule for f over g, derivative of the quotient function. Okay, so I'm just going to now apply it here. So the derivative in this case, because we are calling this whole function as f, now this is going to be derivative. First I have to find the derivative of the numerator, and let us go ahead and find the derivative of the numerator. They're already in that nice form, x to the power n form, so it should be it's not too difficult for us to write the derivative for this numerator. So in parentheses, guys, I'm going to write it in parentheses because there's more than one terms here. So it's going to be 5x to the power 4 plus 4 times 3 is 12x cubed, right? Because 4, you have to multiply that with the 3, and then the next one is you just bring that 3 in the front, and x squared. And then what do I have? Minus 6x. That is going to be my the derivative of the f function. What do I have to do with the g? We don't have to do anything. We just have to write it, multiply it, and it's x squared plus 2, right? And then, guys, I want to have it in just one line. Let me see if I can actually have it in the one line. Well, I may have to get rid of this. We already know the formula, so it's fine. We can get rid of this. Then, guys, what do I have to do next? Next, I have to find the derivative of the g function, and derivative of g is not too difficult. It's just 2x, because derivative of 2 is just constant. 2 is a constant, the derivative of 2 is just 0. So it is 2x, and then what do I have? Then, guys, I have, this is my g, and then I just have to write the f function without doing anything with it. So it's x to the power 5 plus 3x to the power 4 minus x cubed minus 3x squared. And then this whole thing, guys, has to be divided by the square of the denominator, which is x squared plus 2 whole square. And guys, I'm going to leave it like this because the problem did not tell me to simplify or anything, so I'm going to leave it like this. Now, if your problem on your homework or the textbook or the test or the quiz says you got to simplify as much as you can, guys, then we cannot just leave it like that. Then we may have to distribute this and combine like terms. and you can easily do that as well. But in this case, it does not tell me to combine, like it does not tell me to simplify, so we can leave it like this, and you guys can leave it like that as well. Even if it looks messy, it looks, I mean, it does not make sense, but that is fine, guys. That is like some of the problems in calculus. Sometimes they don't just make sense when we are doing the computations. Of course, if you like think of them in context to some real life application, then these things are going to definitely make sense. But for now, guys, if it does not tell you to simplify, even if it looks as weird and as like complicated as this, you just leave it like that. Okay, so this is how to use the quotient rule, and I tried to actually include this extra piece here so that you can see what happens if you have like a product and a quotient going on at the same time. So again, what I did here was I just multiplied the quotients right away so that I don't have to use the product rule first and then the quotient rule. But I could have still used the product rule first and then the quotient rule. I would still got the same answer. Okay, so guys, this is example 3. In the next video, I'm going to be doing an application where again I will talk about how to write an equation of a tangent line, but we'll be using the quotient rule, and because the function will be as a quotient or as a rational function. Okay, till then, guys, take care. I will see you next time.